the next speaker as a dog, and the name is Linux or Linux. Linux. Yep. Poor dog. So I don't want to say anything about JavaScript. I just want to talk about the dog. So I leave you the stage for refactoring large JavaScript code bases. Michele Riva.
Yeah, thank you. Welcome everyone, and thank you for being here to my talk, Refactoring Large JavaScript Code Bases. Before we start, let me introduce myself really briefly. I am Michele. I work as a senior software architect at Neoform. I'm a Google developer expert and a Microsoft MVP. I'm also the author of Real World Next.js, which is a book I just published about Angular. No, I'm kidding. Next.js, of course. And if you want to exchange a couple of words about it after the talk, I'd be glad and I'll be around to talk about it. Couple of words about Neoform. We're a professional services company. We are specialized in Node.js, React, and GraphQL, and whatever. We are authors and maintainers of many open source packages, which gets downloaded 1.2 billion times per month. So in case you're interested in a full remote and distributed team, international team, I'll be around for that too. But that's not why we are here. Let me talk about refactoring. I wanted to talk about refactoring for a very specific reason, and that's because refactoring is damn hard. And it's not just hard refactoring, it's also inevitable most of the times. And it's also really useful, actually. So I really want to talk about this, and as a destroyer of code bases, I want to let you know what could possibly go wrong with that. So let's take this code as an example. So we basically run, we reject a promise on node 14, for example, and we get the following warning. Not an error, that's a warning. We get a 0 exit code out of this, but it will also say, hey, you know what? This is perfectly fine code, but if you try to run this on the newer versions of the runtime, it will terminate the process and exit with a non-zero exit code. Specifically, that will throw a 1 as an exit code and will terminate the process. In fact, if you try to run the exact same script on node 16, you will get the following error we just discussed. Why I'm telling that? Because in 1 year from today, node 14 will be out of maintenance mode, and we will have to refactor all the promise rejections we don't catch with a try-catch block or a catch block, of course, against the promise. So this is why it's mandatory to refactor the code sometime. But it's not just about being forced to refactor the code base. It's also, as I said, something pretty useful and sometimes needed, I would say. So let's take the following code as an example. We have an object with some nested properties, and on node 12, for example, or older browsers, if we want to access the middle name property and we're not sure it actually exists, we basically null check against all the previous properties. And so we say, okay, I want to access middle name, but I will try to see if user data exists, and it's not a null pointer, basically. Then user data name and user data name middle, otherwise no middle name. It's totally fine. This is really good code, actually. If you encounter such code in production, well, I mean, this is strong. Don't refactor that. But I'm telling you that for another reason. Let's take this as an example. On node 12, this is going to crash. And this is also going to crash on older browsers. We are using the optional chaining and Aldish coalescing operators here. And you can use them starting from node 14. So this is going to work fine on node 14. This is going to crash on node 12. So why I'm showing you that? Because before Node accepted the implemented the optional chaining proposal and the nullish coalescing operators, we used to do that. We used to use Lodash, for example, or Ramda, or other libraries, which are exceptional. I mean, these are good libraries. I'm totally fine with them. We just have a couple of problems, actually. So if you run this code on Node, you will give basically on Node 14 and further you will give some overhead to function executions because you have to call external libraries, you have to call basically other functions that are not really needed because we have native support now. And if you try to run the same code on the browser, you will have a bigger bundle, basically, which if you only use get, still fine. If you use the whole Lambda or Lodash or underscore library, I mean, that can be painful for our users. So we may want to get rid of this at a certain point. And it's not, of course, just about Lodash get. It's about all the methods that now are implemented from ES6, for example, and on. So if we get, for example, filter, why should I use filter? I mean, it made sense before ES6 when we didn't have array.filter. Same for map or object keys or even isString is function. We have type of. So why should I use an external library? Again, it made sense back then. We could refactor now. It's not really mandatory to use this. The problem is, okay, we know what we want to get rid of, but what if we have thousands or hundreds of thousands of files to run the migration on? So that's the problem I want to discuss today. Okay, I lose track of my time, so I'll go. Let's see where are we going. So I have two approaches for you. I tested both. Most of the time I failed. As I said, I'm a destroyer of code bases, so I've learned something, and I want to talk to you about what I mistaken, what I did wrong. So approach number one, it's divide and conquer. We might be actually quite familiar with the concept because of algorithms, basically, and we can approach this to project management, which is the perfect topic for a developers conference. I know you all must be really excited to talk about project management, but that's actually a good way for dealing with such problems. So let's get into this. We can separate the whole process in 5 different steps. First one would be to divide the code base using code owners. How many of you is familiar with code owners? 1, 2. Okay, great. Let me explain how they work. So basically, there is just one file inside your repository. This will work on Bitbucket, will work on GitLab, GitHub, whatever you want. And you can assign individual files or folders or subdirectories to teams or individual contributors. So, for example, let's take line 13. We say that libraries and utilities that in a, let's pretend we have a monorepo. We have packages /lib, and everything inside the library folder will be assigned to Michele Riva, which is me, a platform team, and architecture team, who's made up of other developers. Every time someone opens a PR, modifying at least one line of code in any of the files inside the library folder, they will have to request for our approval. And we can decide how many minimum approvals you might have. We can say, okay, you're modifying a utility, you need at least 2 approvals from either me or anyone in the team you're looking at now. So you preserve code quality because I'm the owner for that part of the code, and I can ensure that your change won't break anything. Also on a, let's say, philosophical point of view, not just breaking stuff for the sake of breaking, which is fun, but on the philosophical point of view, I want the code base to be consistent. If I have to, let's say, implement something new and I have to write end-to-end tests, and I do that using Cypress, I want the QA team, which is made of, let's say, John Doe and Jane Doe in that case, I want them to approve my PRs so that they are the area of expertise about end-to-end testing in that case. So I want to make sure that I have the approval from the right people, basically. We will see later why we need that, because the second step is actually a bit different. So let's say we want to remove lodash.get, okay? Which, again, I will never say that enough. It's fine. It's totally fine. Don't do that unless you're forced by many reasons, but it's an easy example for us. So, second step, create or install linting rules. So we can use ESLint in a warning stage saying, okay, you know what? On the staged file, when you're about to commit, you've made some edits to a file that includes lodash.get, so please get rid of it and refactor it using the optional chaining, for example. let's say we have 3 months for doing that. So after 3 months, hopefully, we touched a lot of the code base, and we are starting a refactoring. So one commit at a time, we are replacing all the currencies for the lodash.get method. And we can introduce the error stage. So you had 3 months. Now you can't commit unless you get rid of what I want you to get rid of. So, for example, if you try to commit code containing lodash.get, and we can use Git hooks, basically. We can use commitizen, Husky, and whatever to control and run a linter on staged file only. And we can say, OK, you haven't done your job, so please refactor this code base for me. And I know this sounds bad, but at a certain point, you had 3 months to refactor this code base. And the problem is sometimes we know we have to patch production, sometimes we have to run a really quick fix and we don't have time to refactor, write unit tests for our refactors and whatever. So it's okay to give time to people to align to the code base, to the new rules. Okay, the fact is, for the fourth point, there are parts of the code base that we actually don't want to touch for no reason at all. There are parts of the code base, even when the code base is big, there's likely the opportunity that some of the parts of the code base are really, really old, and we don't want to touch them at all costs. We want to avoid it. So it's likely that we are not running any linting rule on them. That's cool, but at a certain point, we have to fix them too. Otherwise, all we did was worth nothing. So that's where code owners enters the scene. We basically run the linter on the whole code base, and we say, okay, you know what? I've seen that inside the packages utilities, I've seen many occurrences of this linting error because you have lodash.get. So please get owners of that package, please get rid of that. And we give time, basically. Another month, 2 months, 3 months. It really depends on the teams, on how big it's the code base, etc. So we do assign the remaining parts to code owners. And at a certain point, code owners won't fix everything. I promise that will never happen. So we basically want to have a kind of platform team that takes the ownership on the remaining parts, if strictly necessary. I would love not to be in that situation, but we all know we are not living in an ideal world, so that happened. So we need someone, probably a leadership team, wanted to take charge of doing the remaining parts. Okay, I see a couple of pros and cons about this approach I want to discuss with you. So this approach has one big pro. It ensures correctness of the code base on multiple levels. So given that you are refactoring manually, I think you think more about what you're writing in that particular case. Also, it forces you to write unit tests because if you don't have tests ensuring that your edit is not breaking anything, I do encourage you to write some. So it ensures correctness of the code. It also allows incremental adoption of changes, which is good. As we saw, it is not required for us to run everything in 1 week. We can do that incrementally in months or even years if necessary. But also, and that's the most important part for me, everyone is responsible. There is not the concept of having a junior engineer who's doesn't really care about the code base. No, they're a code owner, so they need to be part of that change, and they are responsible. And it's also future-proof, because we are adopting a common view on how we want to write code from now on. So in the future, it's unlikely to have someone importing again the package we are getting rid of. So that's quite good, because we are defining a standard. That also has some cons. It requires a lot of time. We've seen that in 1 year from today, basically, Node 14 will be out of maintenance mode. And what if we have just, let's say, 6 months to migrate to Node 16 because of company policies? We might not have the time to run a large-scale refactor as such. So we may want to choose another thing that we're going to discuss later. It also requires great team effort, actually. So you need different teams, coordination between teams. You want leaders to talk to each other to understand how to implement those changes, how to test them, how it's going, basically. So a lot of meetings. No one likes meetings, right? So that's kind of a problem to me. And that brings me to the second approach, which is called codemod. I don't want you to mistake codemod with that, because there was an amazing library written by Facebook, which was called codemod. It was a CLI tool built in Python that basically it's able to run a regular expression against a a large code base, and get the output and replace it with something else. As you can see, you can say, oh, I've taken this from the README file. So, okay, codemod in that directory with the, please run the code on all the files with the following extensions. So PHP, HTML. The term codemod remained. So whatever we're going to see from now on, we can call it codemod, but please don't mistake it for the library codemod. In fact, we want to talk about JSCodeShift, which is another awesome library written by the guys at Facebook, and takes a totally different approach, actually. In order to understand how JSCodeShift works, we need to understand a bit how compilers works. Because basically, JSCodeShift works here in the transformation phase. So from now on, I'd like to discuss with you how compiler works. And give me just 1 second to see how much time I have left. Oh, yeah, I have time. Great. So I will make this really simple. I know in the audience there is people working on that. Please don't roast me. I know. This is really shallow. But first phase is tokenization, basically. We scan the code. We get individual tokens. For example, var foo equals 10. We have 4 tokens. So var foo equals 10. Then we can start syntactic analysis on the code, and we create a parse tree, which is also called concrete syntax tree. Why do we call it that way? Because it maintains the syntax and the variable names and whatever, and all the values inside the tree. So we can start the analysis on the code base. And then abstract syntax trees. One of the most dangerous things you will see today. So why it is called abstract? Because as you can see, all the values, all the variable names, they just don't matter. It's not important at this stage. We just want to know logically how the code is going to be executed. Just for giving you an example, we have var foo equals 10, which is a variable declaration. Inside the tree, we have a variable declarator, which is singular because we can actually instantiate more variables on a single line. So we can say var foo equals 10, comma, bar equals true. So we might have multiple variable declarators. Then we break down the variable declarator into the identifier, foo, and numeric literal, which is 10. It could have been a Boolean literal with true or false, a string literal, an object, an array, whatever. Okay, before I spoil you that, so this is a nice way to look at the abstract syntax tree, AST from now on. But this is how you're going to deal actually with ASTs. And how do you read that? How do you traverse the tree? So if you want to go in the, let's say, numeric literal, how do you access it, given that it's highly dynamic? The first time someone explained me how abstract syntax trees works, that was me. Yeah, fine, awesome. Yeah. I understood everything, sure. But eventually, I started understanding that people is smart, and developers are actually smart. So they implemented something called the visitor pattern. So this is how JSCodeShift implements visitor pattern. Basically, we don't have to look and traverse the tree manually, but we say, okay, dear JSCodeShift, please give me all the identifiers only. So JSCodeShift using recast or Babel basically parses the code base for us, so we don't have to write our own parser. That would be mad. And say, okay, give me just the identifiers. And for every single identifier, if the identifier name, so identifier is like variable name in that case, if the variable name contains old name, just replace it with new name. So that's the second phase of the compiler stage. So we had parsing. We don't care about it right now because JSCodeShift parses it for us, but we care about the transformation phase. And this is the result. If we have a variable name containing, for example, old name as part of old name factory, we run JS code shift with the following rules we just seen, and it will get refactored into new name factory, for example. JS code shift, it's really fast. It's multi-threaded, so actually it uses workers to run code in parallel. So it divides the code base automatically, unless specified, on as many more workers as it can, and run the code in parallel on different folders and subdirectories. So it's really, really fast. Now, let's make another example. Let's say we have a React component, and we want to get rid of the myHeader component. As you can see, we have to remove it from line 1 and line 6. So on the left, the input, on the right, the desired output. We can do that using JS code shift again. So we use Babel again. We use our Babel configuration, which is good at parsing JSX. And we can say, OK, let's instantiate two different variables, so without element and without import. Go parse the file. So on line 6, for example, you see J file source. That means read the source of the file I'm currently working on. Then on line 7, find JSX elements only. We don't care about literals. We don't care about identifiers. We only care about JSX elements. Then for every single JSX element where the name is myHeader, we take its path inside the abstract syntax tree and prune it. So we basically remove it forever. And we do the same for the imports in that case. So of course, this is working with the import default. So if you have an export default myHeader, this is going to work. If you do export header, which is recommended, this is not going to work. But for sake of simplicity, I made it this way. But as you can see on line 16th, we have j.import default specifier. So again, we are specifying we only want the default one. We don't want the secondary ones. Okay, learning how abstract syntax trees works, it's really important because as I said before, we might want to create specific linting rules for our code base. I couldn't write a very concise linting rule with ESLint for load-get, so forgive me, I had to make, I didn't make this, I actually took this from GitHub. But we basically say, okay, this is another kind of implementation of the visitor pattern. And we basically return an object containing all the properties we want to get. So we say, please, give me all the template literals. And for every single time that I get a template literal, report an error. We have the node and the message we want to spawn as an error message. Then we can say, in that case, we can have a fix. You know, when you run ESLint, you can say -- fix. So you can provide actually a fix. And you can say, if the node expression contains, if the template literals contain an expression, then we are too lazy, we are not going to refactor this. But we are going to replace the first and the last characters, which are the backticks, basically, with double quotes. So we do not only provide a secure fix, we do also spawn a warning or an error message. So knowing how the visitor pattern works, knowing that there is the possibility to do that, it's important when you have to work on large-scale refactors, because as we've seen, there are many different approaches to that, and this is one of the possible ones. Okay, I wanted to show you, let me switch briefly. Okay, so there is an amazing website called astexplorer.net, possibly one of the coolest websites out there. And it allows you to choose a specific parser. For example, here I'm using the TypeScript one for some reason. A language, we can also parse HTML, TypeScript, whatever we want, basically. And it provides us an interface to the abstract syntax tree. So I'm going to show you how that works. So here, as you can see in my mouse, yeah, you can see it. So on the first square, we basically have our code, the one we want to refactor. As you can see, import get from load-get. And then we get the middle name using the get method. Then, on the right, we have access to the abstract syntax tree. So let's take an example. Expression statement. And this is all the data we have, and we can debug it in real time. Going down, let me do that. This is a plugin I found on GitHub. I'll give you the credits right in the next slide. We basically can write our JS code shift rules. So I know this is quite scary and quite big. There's no way I can explain this in like 10 minutes, so I'm not gonna do that. But I will give you the possibility to read that after the talk, of course. And in real time, in the last square, we will see the result. So basically, what we can do here is, okay, I'm importing get from low-get, and as you can see, we get rid of it right in the last square. And we can also say, okay, let's try import get. As you can see, now it's not working, but we can test this, which is working. We can also say, let's say const m equals, let's say user, and then user data, and user data name, let's say, or 0. For some reason, it's just for simplicity's sake. As you can see, it gets refactored too. And I want to give all the credits for this to this repository because it's really, really awesome. And I couldn't suggest you more to dig into the code base here or to understand how JS code shift works. This is really well made, well commented, which is also nice to know when you have to learn something different. Yeah, that's basically it. I want to also share with you the following repository, Awesome Codemods. It's a collection of JS code shift code mods, and you can basically find wherever you want here. So feel free to give it a try. But what are the pros and cons of that approach? First of all, it's really quick. And it's not just about the execution time. I mean, we can have just one or a couple of developers working on that for like a couple of weeks, 1 month, and we are saving months or years of refactors. It requires less team effort for that reason. We can take a good developer from team A, another good developer from team B, make them work together and have a good result. It won't affect other teams directly. So while I'm working on that refactor, all the other teams can work on something else, so they are not blocked by me. At a certain point, I will make a huge PR, which I know it's bad, but we have other, we've seen how to avoid that. So you take a decision to make a huge PR at a certain point, and you introduce all the changes in one time, which can be a con, but let's discuss other cons. So as a first thing, I would say, for you to run this, you need good computer science skills. I don't mean a computer science background because I don't have one. I'm self-taught. But you need to understand what ASTs are, what code mods are, and how the code is going to break if you do the wrong thing, which I did. So I know how it breaks. Tests, for that reason, are absolutely needed. I've been saved by tests. So if you don't have a high testing coverage, don't even try. Don't even try. And QA, in any case, is a must because we are smart, we write tests, but QA sometimes is smarter and they can find a way to blow our code. So I want to give a personal opinion on that. I don't have a preference. I mean, I like JS code shift because I'm a nerd, so I like to write code. But for example, if we have to refactor the promise rejection problem, I wouldn't do that with the JS code shift because it might require some more thought because you just can't append a catch block somewhere and hope that it's working. I mean, you have to deal with the rejection. You have to do something about it. So it's not just about fixing the problem. It's about fixing it the right way. So I would discourage the usage of JS code shift unless you are, you're able to understand the purpose for the code you're gonna modify with your code mod. Other times, I do prefer JS code shift because the team is blocked. We have to deal with a competitor. We have to go to be fast on the market. So I only take a couple of people and I say, okay, let's work on JS code shift. The other team will bring money to the company, basically. So that was all. I hope you enjoyed the talk. I'll be around. Thank you for being here. These are my contacts. Please follow me on Twitter. This is where I live most. And I'll be around if you want to discuss about refactors, JavaScript, or whatever. Thank you.
Thank you, Michele. Thank you. How are you?
All right.
And same question. Do you have any question in the room? Otherwise, I have a question.
Okay.
No question. Are they alive?
I didn't hear anything.
Anything?
Okay.
I hope they enjoyed.
Yeah.
But, okay. I have two questions. I go with the second. How could a person prepare working on a tool such as JS Code Shift?
So how should they prepare working on JS Code Shift as a tool?
Yep.
I would say you have to understand how JavaScript compilation works. You can try using Babel, write your own Babel plugin, and try and understand how to interact with the AST. Or there are many different parsers out there. There is Recast, there is TypeScript itself. So you can try and understand how the compilation phase works. This is the most important thing. Once you're familiar with the visitor pattern, then you can do basically whatever you want on your code base. It's really dangerous, so be familiar with tests and ASTs. That's the only thing I can, let's say, suggest to anyone.
Thank you. We have questions from Hopin. Okay, Stefano Valicchia is asking, SSLint can actually fix things. Why don't you use it to refactor code too, as you are enforcing rules anyway?
Yeah, that's an awesome question, actually. So the problem you have sometimes is that, as we've seen, you need more thought about the refactor. So same for the promise rejection thing. You can just expect to append a catch block or wrap something into a try catch and fix the error forever. You need to handle it. And by doing that automatically, you're getting a high risk, in my opinion. So sometimes you want to deal with the rejection, in that case, for example, and report it. Write it somewhere, do another action because of the rejection. So you can't just delegate this to a try catch. It wouldn't be fair. So it is fine to use, for example, Babel. You can write your own Babel plugin and run it against the code base. You get the same result. You can do the same with Prettier, with ESLint, absolutely. But sometimes you just can't do that.
Okay. Another question from Luca Menghini. I'm missing the extra value of doing this programmatically instead of leveraging any of the tools modern IDE provides us to refactor. Do the breakdown beyond a certain amount of code?
Okay, no, it's not the problem about refactor. So it's maybe someone has a different opinion than me on that, but there are languages that are easier to refactor, actually. If we talk about Java or C#, for example, you have a nice IDE which is well made and well integrated with the language, and the refactor will be smooth. If you're using Visual Studio Code, for example, which is awesome, and you're using that on untyped JavaScript, this is going to be a bit more painful. So you can absolutely do that, but first, you have to do that by hand, and second, I feel like you wouldn't spend less time at the end of the day. So to run I mean, it depends on anyone. So, for example, you can write a good JS code mod in 1 week or 2 days or 3 weeks. And maybe that saves time compared to using IDE capabilities because of how the language is structured and how you can basically run the code mod. So if you're comfortable using an IDE, that's fine. I personally don't. I prefer running JS code mods, and I find comfortable with them.
Thank you. You go? Okay. Yeah, this will be an hard question.
So thanks for the nice talk. I mean, it was
you.
really informative. I have a question about, is it possible, or I mean, are there tools that also allow doing type-driven refactoring? Like, are there ISTs that give you the typing information so that you can decide what to do?
As far as I know, you can't do that directly, for example, with JS Code Shift. You can try with TypeScript. There is an awesome plugin called the T-TypeScript, which basically you can attach it to the TypeScript compiler and inspect the abstract syntax tree as soon as it gets modified by TypeScript itself. So you can inject code before or after the TSC command has run. and then you can understand the types. You can access the type system and do whatever you want. I would suggest you trying that. Never try that approach on JS CodeShift. I did a couple of experiments with TypeScript, so I know you can do it. It's not easy, that's for sure.
Okay, another question from home. How would you approach a product migration from front-end framework to another? For example.
Sorry. Okay, I have one, and then I'll let you finish.
Okay.
So there is an awesome repository on Next.js, which is called Next.js CodeMod, which migrates from Create React App to Next.js. It's well made. I would suggest anyone looking into that, because it's doing the exact thing they're asking.
Okay. So
before I forget. Yeah.
Do you have something? I restart or?
Oh, as you prefer. I'm here.
Okay. Will you approach a product migration from front-end framework to another? For instance, Vue to React or simple Vue 2 to Vue 3. Do you think a tool like JS CodeShift could be useful in the process? This is Francesco Ludovici.
Okay, so between frameworks, I wouldn't recommend doing that. So if you have Angular and you want to migrate to React, no, do that manually. It's safer. From Vue 2 to Vue 3, it might be possible. I think the effort would be too high, actually, because you have to go through many different possibilities in the abstract syntax tree. So you really have to do a lot of stuff. And this is the case where doing, a more granular approach to the refactor can actually be useful. I think JS CodeShift, for example, can be useful when migrating from Create React App to Next. That's totally fine. Or from Vue.js to Nuxt. That's fine too. I wouldn't recommend upgrading to newer versions or from one framework to another doing that. It is technically possible, but I never heard of anyone doing that.
Thank you. The last question from Davide Baldassarre. When would you use a replace all for syntax refactoring?
Oh, because you can also be very good at regex of, I don't know how to pronounce regex, regular expressions. But for example, if you have a string containing an identifier that you want to get rid of, you will be getting rid of it inside the string too, and you don't want that. You can also be good, as I was saying, on regex, but you won't solve the problem. You have to write very large regexes, and believe me, you don't want to do that. So find and replace, it's not an option on large-scale code bases.
Thank you so much, Michele.
Thank you.
Thank you.